It appeared without warning, silent, distant, impossible. Something crossed our sky, and it didn't behave like anything we've ever seen. Every telescope turned toward it, and the world held its breath. Some said it was a comet, others whispered it was a signal, but no one could explain why it moved like it was alive. Tonight you'll follow its path, through silence, through science, through wonder itself. And if you came here to fall asleep, you've come to the perfect place, because here, your mind will drift, your body will rest, and your dreams will teach you what reality hides.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
Far beyond Mars, somewhere in the cold expanse between dust and sunlight, an object is moving faster than anything built by human hands. It isn't supposed to be there. It isn't supposed to exist at all. Yet tonight, it crosses a silent threshold, 19 million miles above the red planet, dragging behind it a shroud of gas that burns like a dying star S-whisper. Astronomers call it 3I Atlas, the third confirmed visitor from another star system, and already it's rewriting what we thought we knew about the cosmos. The night sky doesn't tremble, but the data feeds do. Spectrographs pulse, telemetry streams chatter, and for a brief moment, every telescope trained toward Mars shares the same pulse, the rhythm of discovery. On Earth, observatories relay the numbers in disbelief. An object racing at over 200,000 kilometers per hour, shedding carbon dioxide in impossible quantities, its trajectory hyperbolic, its chemistry off every known chart. If it were merely a rock, it wouldn't glow. If it were a comet, it wouldn't behave this way. If it were something else, no one dares to finish that thought out loud. Somewhere in the quiet corridors of space agencies, voices lower to whispers. 3I Atlas isn't just fast. It's heavy, dense, far more massive than its faint luminosity should allow. Instruments on the James Webb Space Telescope see its spectral signature flaring with carbon dioxide 8 times stronger than water vapor, a ratio that makes no sense for a natural body. It's as though the chemistry itself is rebelling against the laws that govern ordinary comets. And yet, for all that activity, it barely moves under its own exhaust. By every known physical model, that's impossible. But here it is, defying the math, skimming past Mars, and offering us a fleeting window to witness a traveler from another sun. Imagine looking through the lens of an orbiting probe around Mars tonight. Against the crimson haze of the planet's limb, you'd see a pale plume, faint but persistent, sliding across the darkness. The cameras would struggle to track it. The instruments would blink between overexposure and silence. Somewhere within that glow hides the nucleus, a chunk of matter perhaps 5 kilometers across, perhaps smaller than a skyscraper, shrouded in a coma of gas that tells us nothing certain. Every image reveals more mystery. Every data point makes less sense. Astronomers aren't strangers to anomalies. They live for them. But this one feels different. It feels ancient, deliberate, as though some immense story is unfolding at a scale we can only glimpse. Since its discovery by the Atlas survey on July 1, 2025, it has captured the full attention of our instruments, our imagination, and our collective unease. For the first time in recorded history, Mars is not the focus of our gaze. Something passing beyond it is. The excitement began innocently enough, a faint streak in a sequence of sky monitoring frames. When the orbit was computed, the realization came fast and cold. Its path wasn't closed. It wasn't looping around the sun like an asteroid or comet. It was open, hyperbolic, meaning it came from the stars and will soon return to them. Humanity had seen this before twice. In 2017, the object called Oumuamua slashed through the inner solar system like a splinter of light, moving too fast and too strangely to explain. 2 years later came 2I Borisov, a far more ordinary comet that reassured us the universe still played by its own rules. Then silence, until now. 3I Atlas, bigger, brighter, heavier, has come to disturb that fragile sense of understanding. The numbers refuse to agree. Depending on which model you trust, the nucleus could be 300 meters across or 5 kilometers wide. That's not a margin of error, it's a chasm. The brightness says small, but the dynamics say enormous. The chemistry says volatile, yet the motion says sluggish. It's like watching a volcano vent steam without losing mass, a paradox that shouldn't exist outside equations. And still, every orbiting camera insists it's real. The European Space Agency's Trace Gas Orbiter, looping around Mars, picks up wisps of spectral data, faint echoes of CO2 and carbon monoxide fluttering in the solar wind. The Mars Express transmits optical readings that suggest an uneven coma, tilted slightly away from the Sun as if reacting to forces no one has modeled. Scientists cross-check with data from JWST and Hubble, aligning light curves and trajectories until they realize something unsettling. The non-gravitational acceleration is almost non-existent. In other words, it's outgassing fiercely, but it isn't being pushed by that gas. The natural reaction would be motion. What we see instead is stubborn stability. That single contradiction divides the scientific community into factions. The first insists it's a comet, albeit a peculiar one. The second, smaller but louder, refuses to rule out the unthinkable, that it could be artificial. Harvard astrophysicist Avi Loeb, known for courting that forbidden possibility, has already placed 3I Atlas on what he calls the Loeb scale, a measure from 0 to 10 of how likely an object is to be technological. For now, his estimate sits at 4, not proof, not even a claim, but an invitation to wonder. And wonder, in astronomy, is a dangerous thing. Because wonder makes you look closer. Wonder makes you question data that otherwise would rest quietly in an archive. And wonder can keep you awake at 3 in the morning, staring at faint lines on a monitor, imagining that something out there might be watching back. Across social media and late-night newsrooms, the headlines have already taken flight. Alien craft over Mars? Harvard scientists' 60% claim. The truth is less sensational, but infinitely more haunting. We don't know what it is, not yet. What we do know is that the odds of finding an object this massive, this chemically bizarre, as only the third interstellar visitor in our history, are astronomically low. Luck, some say. Others suspect design. The irony is that 3I Atlas is passing by unseen to the naked eye. You could look up tonight and never notice a thing. Its entire journey, a cosmic performance of unimaginable scale, plays out in silence. Only machines, orbiting high above Mars, are close enough to witness the drama unfold. They are our eyes in the void, watching an emissary from the unknown glide past another world, leaving behind a trail of numbers and questions. Somewhere inside that glowing coma lies a message, though not the kind written in language or code. It's a message of physics, chemistry, and motion, a statement from the universe reminding us that the familiar is fragile. Every measurement suggests we've missed something fundamental about how matter behaves beyond our solar cradle. Perhaps it's just a peculiar relic of another star's debris field. Perhaps it's something else, something crafted, abandoned, or disguised. And as it arcs past Mars, our window is closing. The data we collect tonight will define how we talk about interstellar visitors for decades to come. If there's anything to be learned, any secret buried beneath that shimmering veil, it must be found now before 3I Atlas vanishes back into the interstellar dark. The orbiters record, the telescopes hum, and humanity waits, breath held, for an answer that may never come. For now we call it a comet, but the numbers, like whispers in the static, suggest otherwise. Mars, silent and red, watches it pass, its thin atmosphere untroubled, its dust plains reflecting a faint glimmer from something older than the planet itself. By the time the signals reach us, the visitor will already be gone, leaving only questions orbiting our minds. Yet this is just the beginning, because every mystery that arrives from the stars eventually forces us to look inward, to ask what we might recognize as proof and what truths we might already be ignoring. The next chapter of this story isn't about what 3i Atlas is doing in the Martian sky tonight. It is about what the data will reveal when the silence breaks, and what happens if the answers don't fit the world we thought we lived in. The first images arrive in fragments, streaks of static laced with stars, data packets delayed by millions of kilometers of distance, and a few heartbeats of human impatience. Inside mission control rooms in Pasadena, Darmstadt and Bangalore, monitors flicker with ghostly green plots, translating photons into meaning. No one breathes as the first processed frame clears. There it is again, 3i Atlas, just a blur against the black, but real, undeniable, alive in motion. The orbiters around Mars had been watching for days, but tonight they caught something new. The coma surrounding the object ripples unevenly, like fog disturbed by an invisible pulse. Spectrographs register spikes, then silence, then spikes again. To the untrained eye, it's noise. To the scientists who have spent their lives interpreting the language of light, it's something else entirely. Patterns, rhythms, almost like breathing. Across the control rooms, commands are sent, telescopes realigned, instruments recalibrated. The trace gas orbiter begins its scan, dissecting the faint light from 3i Atlas into spectral lines, each color revealing a different molecule. The results roll in like whispers. Carbon dioxide dominant, yes, but with erratic bursts of carbon monoxide. And something else, something faint at the edges of detectability. A compound too weak to classify, a trace element that doesn't belong in the family of simple volatiles comets usually carry. The software flags it, color codes it and moves on. But a few people in the room circle back to it, hearts quickening. The Mars Express spacecraft confirms the same odd ratios, its sensors recording shifts every few hours, as though the object's chemistry is evolving. Normally, comets follow predictable thermal patterns. The closer they get to the sun, the more their ice boils away. But 3i Atlas doesn't play by those rules. Its emissions rise, fall, then rise again, independent of solar angle. It ES as if something beneath the coma is regulating the flow, opening and closing vents at its own rhythm. Meanwhile, the James Webb Space Telescope, far from both Earth and Mars, captures deeper spectral data through its infrared eyes. The readings show fine dust grains mixed with frozen gases, but their proportions make no sense. The ratio of carbon dioxide to water remains stubbornly around 8:1, too high, too stable, too deliberate. Scientists debate whether it's even possible for a natural body to sustain that ratio across changing solar conditions. The consensus, if it can be called that, is confusion. In the press rooms of NASA and the European Space Agency, spokespeople prepare statements designed to calm curiosity without feeding hysteria. Preliminary analysis suggests the object is a comet of interstellar origin, one says. Another adds there is no threat to Earth, but no one inside those buildings feels reassured. The data is too strange, the silence between the signals too loud. On online forums and late-night live streams, amateur astronomers dissect every pixel of every released frame. Some claim to see structure in the glow, a symmetry to the jets, a flicker that repeats too perfectly to be random. Others argue it's just instrument noise. The arguments spill into headlines, headlines into rumors, and rumors into the collective imagination of a planet that has always looked for meaning in the night sky. Inside a laboratory in Arizona, a young spectroscopist named Amina reruns the calibration software for the 10th time. She's certain there's no error, yet the spectral spikes don't match any known configuration of natural volatiles. They oscillate, in time. She zooms in, overlaying 6 hours of readings. The peaks form a repeating pattern: 6 spikes, pause, 6 spikes again. She stares until the screen blurs. Could it be rotational modulation? Could the comet's spin expose active regions periodically? Or is it something else, something deliberate, timed like a pulse? She saves the file, tags it, pending verification, and leans back in her chair, feeling the weight of wonder and unease settle over her. Across the Atlantic, at the European Space Operations Center, the debate grows louder. One engineer argues that the rotation period must be short, perhaps 5 hours given the brightness variations. Another counters that the fluctuations don't fit any known rotation curve. The data could suggest tumbling, chaotic spin, but even that explanation frays at the edges. If it's tumbling, the coma should smear in predictable ways. It doesn't. The gas jets maintain coherence like streams guided by unseen channels. An older astrophysicist breaks the silence. "We might be looking at a fractured nucleus," he says. "Multiple vents, aligned accidentally." The room nods, grateful for an answer that sounds familiar, yet no one quite believes it. The coincidence required is too perfect. Back on Earth, telescopes from Chile to Hawaii chase the object, each collecting slivers of data from different angles. The triangulated observations reveal a shape more elongated than spherical, possibly cylindrical. But the coma hides the true outline. Some frames suggest a sharp leading edge, a brightness consistent with a reflective surface rather than dust. When the report reaches headquarters, it's quietly filed under inconclusive. The media calls it mystery, the agencies call it anomaly, but among the scientists, a quieter word circulates: artifact. Not confirmed, not even proposed officially, but whispered in corridors when the recordings stop. The very possibility changes the way people look at the data. Each new measurement becomes a clue, each noise spike a potential message. Avi Loeb, ever the provocateur, publishes a brief note online. Unusual compositional ratios and negligible acceleration invite consideration of non-natural origins, it reads. Further observation required. Within hours, the quote spreads like wildfire. News anchors summarize it as Harvard professor suggests alien probe. Within a day, conspiracy channels fill the gaps with imagination. Humanity, as always, turns uncertainty into narrative. But inside the real labs, the feeling is more subtle. A mix of dread and fascination. Because if 3i Atlas is natural, it challenges our chemistry. And if it isn't, it challenges everything else. The next wave of data from Mars comes in just before dawn UTC. The Trace Gas Orbiter S ultraviolet spectrometer captures an unexpected flash in the coma, an emission spike at a wavelength corresponding to ionized carbon. It lasts less than a minute, then vanishes. No impact detected, no flare from solar-wind interaction, just a pulse and silence. Analysts check for instrument error. None found. The report simply reads, transient event. 1 minute of strangeness suspended in billions of years of cosmic calm. By morning, the pulse has become legend. Theories bloom, a vent eruption, a microfragment release, a resonance from spinning dust. Yet every possibility feels like a patch on a hole too large to cover. The object continues on its path, unbothered, unchanging. In the days that follow, the global network of observatories sinks into a coordinated campaign. Data pipelines merge, models multiply, and the deeper they dig, the less it makes sense. The CO2 jets are asymmetric, yes, but their orientation shifts in a way that doesn't correspond with sunlight or thermal stress. It's as if something inside the nucleus is choosing where to vent next. A week after the Mars flyby, JWST records a faint halo of ice grains expanding from the coma. Within it, a thread-like structure glimmers, a narrow plume of material arcing outward before dissolving. When analyzed, the plume's trajectory doesn't match simple ballistic flow. It curves subtly, as though deflected by an internal force. Maybe it's magnetic, someone suggests, but comets don't have magnetic fields. Not like that. At the end of another sleepless night, Amina opens a live feed from Mars Express. Nothing but static, stars, and the faint smear of 3I Atlas. She adjusts the filter, and for a split second, the noise patterns align into a grid-like texture before dissolving back into randomness. She blinks. The image reverts. Probably just compression artifacts, she tells herself. Probably. The world outside continues on as usual. Traffic, conversations, routine. But among those who know what's unfolding, reality feels thinner, stretched. The idea that something built elsewhere could be gliding past our neighbor planet, cloaked in dust and chemistry, is almost too large to hold. And yet it fits the data no worse than the natural models do. Each day, the object moves farther from Mars, its brightness fading, its enigma deepening. The scientists scramble to interpret the last scraps of information before the signal weakens beyond retrieval. Somewhere between the noise and the known lies the truth, one that might redefine not just how we see the universe, but how we see ourselves. As 3I Atlas drifts into the next phase of its orbit, approaching its closest distance to the Sun, the debates give way to something quieter: anticipation. For in a few weeks it will reach perihelion, where the heat is greatest, the outgassing most violent, and secrets, if any remain, may finally burst into light. But there's another possibility, one that no one dares speak aloud in the official channels. What if it doesn't flare up at all? What if, when it passes the point of maximum heat, nothing happens? What if it stays cold? Because that would mean it's not reacting to the Sun at all. For days after the Mars flyby, the observatories stayed locked on the fading glow. The telemetry kept streaming in, a steady heartbeat from the deep. The further 3I Atlas drifted from the red planet, the harder it became to track, yet the stranger its behavior appeared. Brightness variations that should have followed a clean thermal curve instead stuttered like an interrupted signal. Dust density fell, then spiked, then fell again. It was as if the comet were breathing, slow, uneven, conscious. By the second week, teams at every major space agency were working in shifts around the clock. Some analyzed the chemistry, others modeled the trajectory, and a few tried to build visual reconstructions of the nucleus hidden within the coma. That nucleus had become a kind of ghost, always implied, never seen. Hubble's high-resolution imagery placed an upper limit at about 5.5 kilometers across, but dynamic models suggested it could be smaller, maybe less than half a kilometer. That range, a 1,000-fold difference in volume, was too wide to accept. It wasn't uncertainty. It was ignorance staring back through the data. At the center of the puzzle was mass. Every comet outgasses as it warms, and those jets push it slightly off course, measurable as a non-gravitational acceleration. For 3I Atlas, that push should have been significant, given the violent venting detected by JWST, yet the motion hardly changed. Using the faint drift that was observed, researchers back-calculated a lower limit for its weight: 33 billion tons. To put that in perspective, if it were only half a kilometer wide, it would have to be made of iron. But the spectra said otherwise. It was volatile, icy, fragile. The math refused to cooperate. Someone in an ESA meeting called it the paradox of inertia. The name stuck, The chemistry was no kinder. JWST's infrared sensors measured a carbon dioxide to water ratio of roughly 8 to 1, 8 molecules of CO2 for every molecule of H2O. No known comet in the solar system comes close. Even the most carbon-rich bodies we've studied barely reach parity. When the numbers were first released, the reaction was disbelief. Some suggested calibration error, others blamed contamination from Mars' thin atmosphere. But subsequent readings from different instruments and angles confirmed it. The ratio was real. That ratio became a cipher. Every possible natural explanation was tried and found wanting. Maybe it formed farther from its home star, where carbon dioxide condensed before water. Maybe it spent eons drifting through interstellar radiation fields that baked away surface water ice while preserving deeper CO2 reservoirs. Maybe. The word hung like a prayer over every meeting. Yet something deeper troubled the modelers. The outgassing jets, those thin, bright streams caught in the high-contrast imagery, weren't aligned randomly. They seemed to originate from specific longitudes on the hidden surface, turning on and off with near-periodic timing. In simulation, that behavior created a symmetrical thrust pattern that nearly cancelled itself out. It explained the weak acceleration, but only by invoking geometry so precise it bordered on intention. Balanced jets are possible in nature, but rare. Balanced jets that stay balanced across days of rotation, almost unheard of. A few researchers began whispering that maybe they weren't T-jets at all, at least not in the ordinary sense. Perhaps fractures in the crust were opening and resealing under internal pressure, like valves cycling. Others, more cautious, argued that comets often surprise us. The Rosetta mission had seen similar asymmetries on 67P, but privately, even they admitted 3I Atlas was different. The numbers were too clean. Meanwhile, photometric analysis hinted at an elongated shape, a body that rolled rather than spun. If true, the exposed surface area facing the sun would vary irregularly, which should have caused wild fluctuations in activity. Instead, the emissions remained strangely stable. The energy budget didn't add up. It was releasing too much gas for its estimated temperature, as though the heat were coming from somewhere else. At a conference in Prague, a young computational physicist presented a model that treated the object as a hollow shell with subsurface cavities. The simulation reproduced the observed thrust patterns almost perfectly. When she concluded, the room fell silent. No one wanted to say the word artificial, but everyone was thinking it. As the days passed, the object approached the inner solar regions. Solar radiation intensified, yet the CO2 ratio barely changed. Normally, as comets warm, buried water ice begins to sublimate, shifting the ratio toward unity. Not here. 3I Atlas kept belching carbon dioxide as if it were composed almost entirely of dry ice. Its thermal curve flattened where it should have steepened. It was as though the object had already reached equilibrium with the sun, no longer reacting, just enduring. Avi Loeb's latest essay landed like a spark in dry grass. The simplest explanation, he wrote, is not always the correct one, but it should be tested first. However, when simplicity fails, we must not fear complexity. A technological origin is complex but not impossible. He wasn't declaring it alien. He was reminding his colleagues that disbelief is not evidence. The essay made headlines worldwide. Overnight, 3I Atlas transformed from a scientific curiosity into a cultural event. Public fascination surged. Documentaries replayed grainy renders of the object gliding past Mars. Talk shows speculated about contact scenarios. Social networks split into camps, believers and skeptics, dreamers and cynics. And beneath the noise, the real scientists kept working, caught between wonder and professional caution. The next set of readings arrived from the ExoMars Trace Gas Orbiter, a new round of spectra, sharper, cleaner. In them, analysts detected faint signatures of carbonyl sulfide, a compound that forms under specific chemical pathways involving both oxygen and sulfur. Its presence wasn't impossible, but combined with the other ratios, it deepened the oddity. Someone in the data group joked, "This thing's kitchen must be on fire." Nobody laughed. By mid-October, the trajectory modeling had stabilized. 3I Atlas would reach perihelion, the closest point to the Sun, on October 30th. The distance, 1.4 astronomical units, just inside Mars's orbit. At that moment, it would experience peak heating. If it was a normal comet, the outgassing should explode, brightness soaring, jets expanding like solar flares. Every telescope in the system prepared for that moment. And yet beneath the planning there was fear. Because what if nothing happened? What if the object simply glided past the Sun unchanged, indifferent to its heat? That would mean the coma wasn't a product of sublimation at all. It would mean the gas was being vented for reasons we didn't understand. A new hypothesis emerged quietly in the back channels of astrophysics forums, that 3I Atlas might be a fragment of something larger, a shard from a destroyed world, a piece of debris from an ancient catastrophe far beyond our stars. Its composition, skewed toward carbon dioxide, could be the result of exotic planetary chemistry, the residue of a crust boiled and ejected into interstellar space. It would make the object not built, but born from ruin, a cosmic fossil. Others proposed darker ideas. Suppose it wasn't debris, but the remnant of a vessel, its outer hull long eroded, its internal systems dead, still venting trace gases from decaying reserves. A ghost ship adrift between suns, romantic, absurd, but hauntingly consistent with some of the data. The debate became a mirror for belief itself. To some, every anomaly was evidence of intelligence. To others, it was a challenge to dig deeper into natural physics. Both sides, without realizing it, were united by the same emotion: awe. Because 3I Atlas, whatever it was, forced humanity to confront the limits of its imagination. At night, when the observatories shut their domes and the screens dimmed, the question lingered like an afterimage. What if the universe isn't just stranger than we think, but stranger than we can think? Perihelion was still 2 weeks away. The data lines hummed. The glow around the object pulsed faintly against the void. And somewhere deep in that coma, wrapped in carbon fog and ancient dust, something waited, patient, silent, indifferent to the storm of curiosity it had ignited across a tiny blue world. The countdown to perihelion had begun. In the days leading up to perihelion, the silence around 3I Atlas felt heavier than the data itself. Every telescope, every antenna, every probe capable of observing it was aimed at a single moving dot, yet no one could predict what the moment of closest approach would bring. The scientists spoke in the measured language of models and probabilities, but beneath it all was the same quiet, anticipation, the feeling that something about to happen might not fit into any existing box of explanations. The object had now passed the orbit of Mars and was racing sunward, cutting through interplanetary dust like a knife through mist. If it were a normal comet, this would be the point where its true personality emerged. Comets brighten as they heat, sometimes flaring spectacularly when trapped gases burst free. 3I Atlas, however, remained almost stoically unchanged. Its brightness oscillated, but not in the way thermal activity predicts. Every 3 to 4 hours a faint rise, then a plateau, then another rise. The pattern repeated with mechanical precision, as though following an internal metronome. At NASA's Goddard Space Flight Center, a team working night shifts noticed the cycle. They overlaid the light curves from multiple nights, aligned them, and the rhythm fell into perfect sync. It wasn't noise. It wasn't random. Could be rotation, someone suggested, or something venting on a timer. The words hung in the room. They didn't make it into the official report. Meanwhile, Avi Loeb had refined his framework, the now famous Loeb scale, into a more formal structure. 10 points, each representing a step between certainty of nature and certainty of technology. 0 meant unambiguously natural. 10 meant confirmed artificial. Most objects, by his own admission, clustered near 0. For 3I Atlas, the provisional score had once been 6, then dropped to 4 as more natural evidence emerged. Still, a 4 was enough to start arguments across the astrophysical world. In private discussions, Loeb defended his scale as a tool, not a proclamation. "It's a way of disciplining imagination," he told colleagues. "We can't treat every anomaly as alien, but we also can't dismiss the possibility before testing it." His detractors accused him of courting publicity, of blurring the line between science and spectacle. But behind the noise, more researchers were quietly running his calculations, if only to see where their own data would fall. At the European Southern Observatory, a team from Spain and Italy used adaptive optics to capture refined imagery. They saw nothing overtly technological, no symmetry, no reflections, no structure beyond the swirling coma. But they did notice something subtle. The coma's core region had a narrow spine of increased brightness that didn't spread outward as dust normally does. It persisted, faint and steady, like a glowing filament running along one side of the nucleus. The data was too noisy to draw conclusions, but the anomaly was there, unmistakable. By then, the world's media had taken Loeb's idea and turned it into shorthand for belief. News anchors spoke of a Loeb 4 object, as if it were a category of existence. Online debates raged over whether the scale should even exist. The irony, of course, was that the scale's purpose was caution, to keep excitement quantifiable. Yet excitement was the one thing it couldn't contain. Back at Goddard, the carbon dioxide ratio still refused to shift. Each day closer to the sun, the readings should have changed. Water vapor should have surged, overtaking CO2 as the dominant gas. Instead, the numbers held. Some argued that the nucleus might have exhausted its water long ago, leaving only carbon dioxide pockets near the surface. Others countered that if it were so depleted, the activity should be declining, not constant. It was as though the object were maintaining output intentionally. There was a growing sense, whispered more often than spoken, that they might be witnessing something alive, not biologically, but mechanically alive, self-regulating in ways natural processes couldn't match. But science has its rituals. You don't write alive in a draft paper. You write self-stabilizing emission patterns. The public fascination had by now reached fever pitch. Live streams tracked simulated orbits. Animations filled news feeds with glowing, spinning constructs labeled possible probe. Someone had even rendered it as a sleek metallic spindle with blue ion trails. Pure invention, but compelling enough to circulate millions of times. Astronomers fielded questions from journalists who wanted yes or no answers to a question that didn't have one. The truth was less cinematic but far more profound. They were watching an object that refused to fit their expectations, and that refusal was itself a revelation. Inside the European Space Agency's operations room, the mood oscillated between exhaustion and awe. For every dataset that pulled the mystery toward natural explanations, another emerged that pulled it back into the unknown. One model, published quietly in a preprint, proposed that 3I Atlas's jets were being redirected by internal magnetic channels, perhaps due to ferromagnetic minerals buried within. Another paper argued that magnetic fields of that strength couldn't exist in an object this small without external influence. The two studies contradicted each other completely, but both described a world where the object was more than just ice and dust. It was structured. On the evening of October 27th, with perihelion only 3 days away, JWST captured a remarkable sequence, a brief flare of infrared emission that didn't coincide with any change in visible brightness. It lasted 40 seconds, pulsed twice, then faded. No solar flare struck at that moment. No dust impact registered in the surrounding region. When the data reached Earth, analysts ran through every failure mode they could imagine. Cosmic ray hits, calibration error, thermal noise, but none fit. One scientist, half joking, named it the heartbeat. The name spread. Somewhere beyond scientific caution, beyond the endless graphs and debates, a quiet awe began to take hold. For all our telescopes and equations, for all our insistence on control, here was something that answered to none of it. It was real, observable, and yet so foreign, it slipped through our definitions like water through fingers. A few senior astronomers convened a private meeting across time zones. They debated one question: should they consider a close-up probe mission if 3I Atlas remained observable after perihelion? The logistics were almost impossible. The object's velocity was too high, the window too narrow. But the idea of letting it slip away unexamined felt like sacrilege. They didn't know if they were chasing a rock, a relic, or a revelation. But they all agreed. This was the most important thing humanity had ever seen. 2 nights later, the last pre-perihelion spectra arrived. They looked almost identical to the ones before them. No water surge, no chemical shift, no sign of a thermal event. It was as if 3I Atlas were already anticipating the solar furnace, indifferent to the heat that should soon vaporize its outer layers. The coma brightened slightly, not explosively but smoothly like a controlled burn, and then the light began to pulse again, faint and rhythmic, in perfect synchrony with the earlier pattern. 3 pulses, silence. 3 pulses again. When the message reached Loeb's inbox, he typed a single sentence into his notes. If this pattern persists beyond perihelion, we will need to redefine what it means for something to be natural. Outside, in the quiet deserts of Chile and the frozen plains of Canada, telescopes turned toward the sun, ready to watch the moment the visitor reached its zenith. The universe, indifferent and vast, continued its slow turning. But for one small species on one small world, everything seemed to pause, waiting for the star's light to strike an object that might, for the first time in history, answer back. October 30th, the day the world had been waiting for. The day every telescope from the Atacama to Hawaii to orbit itself pointed toward the same spot near the sun's edge. 3I Atlas had reached perihelion, the point of maximum heat, maximum pressure, maximum revelation. Somewhere in that blinding brilliance, within the storm of radiation and solar wind, a visitor from another star was crossing its most perilous threshold. No one on Earth could see it directly. The sun's glare drowned it out. But the instruments, machines that saw beyond light, were watching. JWST monitored in infrared, Hubble in ultraviolet, Mars orbiters at oblique angles. Even the Solar and Heliospheric Observatory tilted its coronagraph, trying to catch the faintest echo. For the first few hours, nothing unusual appeared. Brightness steady, composition unchanged. Then at 1417 UTC, the data shifted. A flash, a surge, not violent but surgical. An emission line blooming at wavelengths corresponding to carbon monoxide, then fading almost instantly. Then another, shorter, weaker. The signals weren't random. They followed the same rhythmic spacing seen weeks earlier. 3 pulses, pause, 3 more. The same timing down to fractions of a second. In labs across the planet, the monitors froze. The pattern had survived the sun. At Goddard, a voice finally broke the silence. It's repeating the heartbeat. The room stayed still. No one wanted to be the first to say what everyone was thinking. It could be coincidence, rotational geometry, synchronized vents, statistical noise. But the odds of that repetition at perihelion, after 200 million kilometers of travel, bordered on impossible. For hours, data streamed in. The object brightened slightly, held steady, then dimmed. Not the wild flare of a comet boiling apart, but the gentle fade of something conserving energy. The CO2 ratio remained constant, the waterline stubbornly quiet. 3I Atlas wasn't melting. It was enduring. By every measure, it should have erupted. Instead, it stabilized, as if anticipating the storm. The solar wind swept around it, dragging the coma into a tail that stretched millions of kilometers. Yet the nucleus, invisible behind that haze, moved with impeccable precision, unaffected by turbulence that should have tossed it like debris. The models predicted chaos. The trajectory remained perfect. By evening, the first global analysis meeting convened. 50 screens, hundreds of scientists all staring at the same plots. The numbers refused to obey physics. The outgassing rate was still enormous, but the corresponding thrust, the tiny push it should impart, remained negligible. They recalculated mass again. Same answer, 33 billion tons minimum. The only way for such a small object to be that heavy was if it weren't porous like ice, but dense, solid, maybe even metallic. Someone asked if it could be a fragment of a planet. Another suggested a dead core of an ancient comet, stripped of volatiles. A younger scientist, half out of exhaustion, muttered, "Or a shell." The word hung there unacknowledged but impossible to erase. The media coverage had gone wild. Live broadcasts tracked simulated orbits. Anchors spoke of the alien visitor defying the sun. Hashtags trended across continents. But the scientists behind the scenes weren't celebrating. They were watching something that made them question the boundaries of natural law. It was exhilarating. It was terrifying. In the midst of the noise, an unplanned discovery occurred. The Mars Express, though now far behind the event, captured reflected solar radiation bouncing off the coma. The polarization of that light didn't match expectations. Instead of the random scattering typical of dust, it showed partial linear polarization, a sign of flat or structured surfaces. On the ground, polarization analysts replayed the data 3 times before believing it. Something inside that haze was reflecting light like a mirror. When the news reached Loeb, he didn't post immediately. Instead, he called a closed session with colleagues. They debated through the night. By morning, one thing was clear. If 3I Atlas had coherent reflective regions, natural or not, it was unique in the known cosmos. But the real shock came 48 hours later. As the object emerged from the sun's glare, telescopes expected chaos, dust trails, fragmentation, a fading core. Instead, the coma reformed, symmetrical, pristine. It was as if the sun had never touched it. Most comets lose mass at perihelion. This one seemed reborn, its spectral signature sharpened, the CO2 spikes now cleaner, narrower, as though purged of noise. "It's healing," whispered a technician at the European Space Agency. No one corrected him. On November 2nd, the JWST recorded an emission anomaly, faint radio flux at 4.8 gigahertz. The spike lasted half a second, just above background noise. It didn't repeat, and no other observatory caught it. Officially, it was dismissed as instrument interference. Unofficially, the logs were preserved in triplicate. By now, the debate had split into 3 camps. The first insisted 3I Atlas was a comet, albeit a deeply peculiar one formed in an exotic system. The second leaned toward the artifact hypothesis, perhaps a fragment of an engineered structure, venting its ancient guts into the void. The third offered a haunting middle ground, a hybrid theory suggesting it could be both, a natural body modified by intelligence, repurposed for travel across the stars. That last idea carried dangerous implications. If 3I Atlas had once been part of something larger, a craft, a colony, a machine, then somewhere in the dark beyond our sun, its origin still existed. In the days after perihelion, the data poured in faster than anyone could analyze it. Teams noticed micro-variations in brightness that followed Earth's rotation. When one hemisphere lost view, the signal dimmed slightly, as though the object were responding to the direction of observation. A coincidence, surely. But coincidences were stacking up like evidence. Governments stayed quiet. space agencies tightened media access. The official line was that 3I Atlas remained a natural object of unusual chemistry. Yet behind closed doors, task forces formed, committees whose names wouldn't appear in public budgets. Their job, to plan what to do if the anomaly continued. In the public eye, 3I Atlas became a symbol. To some, it was proof that we were not alone. To others, it was a reminder of our smallness. Religious leaders quoted scripture, philosophers invoked cosmic humility, and countless ordinary people went outside at night, staring up at a sky that suddenly felt less empty. Meanwhile, the object kept moving, now outbound away from the sun, gliding past the orbit of Earth's mirror world. Its tail thinned, but the core remained bright, steady. Astronomers measured its velocity, 210,000 kilometers per hour, and holding. No deceleration, no loss of mass, just relentless forward motion, as though driven by purpose rather than momentum. In a quiet office, Amina, who had first noticed the repeating signal weeks earlier, watched the new data scroll across her monitor. The pattern was still there, faint but measurable. She ran a fast Fourier transform on the light curve, just to be certain. 3 pulses, pause. The timing matched the previous data, down to the 10th of a second. She whispered to herself, "It's not random." Her voice shook. "It's not random." She sent the report to her supervisor. No reply. Hours passed. When she checked the shared server again, the file was gone. Outside, the night was clear and cold. Somewhere far above, the object from another sun sailed into the dark, indifferent to the questions it had left behind. Humanity had glimpsed it, measured it, argued about it, and yet, for all the data, no one could say what it was. What they did know was this: something had crossed our sky that refused to die in the light of the sun, and in its survival, it had changed us. Because now, for the first time, the idea that we were alone felt not just uncertain but naive. The next phase would not be observation. It would be pursuit. The decision to pursue 3I Atlas didn't happen with ceremony or public announcement. It began as a whisper between mission directors and physicists, buried under layers of contingency planning. But everyone involved knew it meant one thing: humanity wanted to follow, to chase the uncatchable. The challenge was brutal. The object was leaving the inner solar system at over 200,000 kilometers per hour. No existing probe could match that speed, let alone catch it. Yet in every conversation, that fact seemed less like an obstacle and more like a dare. Engineers began sketching trajectories, dreaming of gravitational slingshots using Jupiter, or even the sun itself, to gain the velocity needed. It was madness, and yet after what 3I Atlas had done, madness suddenly felt rational. While the world debated philosophy, the agencies debated propulsion. Some argued for nuclear electric concepts, some for solar sails, others for exotic ideas drawn from the fringe of physics: laser propulsion, magnetic tethers, even directed plasma engines. Anything that could close the gap before the object vanished forever into the dark. But every design shared one quiet, dangerous assumption: that 3I Atlas was more than rock and ice, that it was worth reaching. In the meantime, the data stream continued. As the object receded, its behavior shifted once again. The pulses, the rhythmic emissions first noted before perihelion, grew slower, stretched apart by hours instead of minutes. The brightness dropped, but not smoothly. Each decline came with a faint, structured oscillation, as though the signal itself were being damped intentionally. The pattern reminded some of a heartbeat slowing after exertion. Others saw it as a countdown. On the public side, interest began to fade. The news cycle moved on, leaving only the devoted amateur astronomers, late-night researchers, and those who had seen in 3I Atlas something that wouldn't let them go. For them, every new data release was a holy text, every fluctuation a possible word from the unknown. Inside NASA's Jet Propulsion Laboratory, a small group kept working after hours, unofficially. They called themselves the Watchers. Their leader, Dr. Oumuamua, was an orbital dynamicist who had grown frustrated with the caution of official channels. "We have maybe 2 months of visibility left," he said one night, pointing to a projected orbit fading into deep space. "After that, it's gone. No second chances." Someone asked what he wanted to do. Malik looked at the room. The engineers, the physicists, the 2 programmers who'd stayed long after their shifts ended, and said simply, "We build a message." He wasn't proposing communication in the traditional sense. They had no transmitter powerful enough to reach it, no guarantee it could even detect electromagnetic signals. But Malik believed that if 3i Atlas was responsive, if the repeating pulses were more than coincidence, then maybe, just maybe, it could recognize a mirrored rhythm. A pattern sent back at it, in the same timing it had shown them. Within 48 hours, the Watchers had constructed a plan. They would use the deep space network, leveraging existing antennas to broadcast a narrowband pulse train matching the 3-beat rhythm. It wasn't an official mission, but bureaucratic loopholes have always been easier to find than proof of the impossible. The signal would be weak, almost ceremonial, a whisper flung into the dark. On November 15th, they transmitted. 3 pulses, pause, 3 pulses again. A heartbeat returned to the stars. For days, nothing happened. The object kept receding, the signals from it fading into background noise. The group began to drift back to their normal duties, embarrassed but not regretful. At least they had tried. Then, on the morning of November 21st, one of the data analysts noticed a spike. It was faint, buried in static, but the timing matched perfectly. 3 pulses, same spacing, arriving approximately 71 hours after transmission. Too precise to dismiss, too improbable to accept. Malik didn't speak for a long time. When he finally did, he whispered, "It heard us." The official channels never acknowledged the event. The Deep Space Network logs were sealed under instrumental anomalies. The explanation was simple: reflection, echo, coincidence. But the Watchers didn't buy it. They had sent a rhythm, and a rhythm had come back. Elsewhere, independent observatories confirmed faint variations around the same period, though none were strong enough to be conclusive. Some scientists speculated that the radiation burst was solar interference. Others quietly requested the raw data. The debate spiraled, filling classified forums and encrypted message boards with speculation. Had humanity just been answered, or had the universe simply coughed at the perfect moment? As 3i Atlas moved beyond the orbit of Jupiter, its coma began to thin, revealing sharper photometric changes. The nucleus's rotation period appeared to lengthen, as if it were losing energy or conserving it. A handful of researchers wondered whether it might one day slow to a stop. Others warned that what looked like deceleration could just be geometry, the illusion of shifting sunlight. Yet deep down, most of them sensed something deliberate in the data's restraint. By late November, Avi Loeb released one last public statement. "We cannot yet say what 3i Atlas is, but we can say what it is not. It is not random." And that should remind us that intelligence need not look like us or speak to us to be recognized. The word spread quietly, overshadowed by global news of politics and storms and the ordinary noise of civilization. But in observatories, labs, and darkened control rooms, a different mood took hold, a sense that a line had been crossed. For the first time, something beyond the solar system had behaved as if it noticed we were here. Amina sat at her workstation, replaying the final data set before the object drifted beyond range. The faint pulses were still visible, weaker now, fading into the hum of cosmic background radiation. She ran them through the spectral analyzer one last time. The peaks aligned in harmonic ratios, simple mathematical intervals, like notes in a chord. Whether coincidence or message, she couldn't say, but the symmetry was too perfect to forget. When she looked up, dawn was breaking through the lab window. Outside, the world was normal again. Cars moving, people waking, unaware that their planet had just whispered into the dark and perhaps been heard. She thought of the object, gliding further each second untouched by gravity or heat, an exile between suns. Somewhere in that endless night it was still moving, still silent, still repeating its patient rhythm. No one knew if it would ever return. Maybe it would drift for another million years, carrying within it the same pattern, the same secret heartbeat. Maybe another civilization far away would one day notice that rhythm in their sky and wonder what it meant. For now, all we had was silence, an echo of curiosity sent out and reflected back across the void. By early December, 3i Atlas was far beyond Mars's orbit, racing toward the icy kingdom where sunlight becomes an idea rather than a force. Its tail, once bright and visible even to amateur telescopes, had thinned into a faint filament of silver vapor. The official tracking teams began to hand off responsibility from daily monitoring to long-term trajectory modeling. The event that had captivated humanity for months was now slipping quietly into the archives of cosmic history. Yet for those who had truly looked, those who had seen the data change and felt something vast stirring behind it, the story was far from over. In classified meetings across 3 continents, the Watcher's unauthorized transmission was being dissected line by line. Technicians replayed the signal until the audio was nothing but hiss. Some claimed to hear harmonics, others dismissed it as interference. The internal report used cautious language, unconfirmed pattern coincidence within acceptable statistical thresholds. But Malik knew what he had seen. He had timed it himself. The response came too perfectly to be chance. The odds of random noise aligning with the transmitted rhythm across that distance were beyond astronomical. Still, he said nothing publicly. The world was not ready for another debate about proof. Oumuamua had taught him that much. Evidence is never enough when belief is the variable. The days passed. The pulse intervals stretched wider as the object receded, weakening under the square of distance. Yet even as it dimmed, one anomaly persisted: its trajectory. Normally, once an object escaped the sun's gravitational grip, it should follow a clean hyperbolic path, predictable to the decimal. But 3i Atlas's orbit wasn't perfectly clean. Tiny deviations began to appear, minute, almost imperceptible kinks in its velocity curve. Some blamed measurement error, but the pattern was consistent across instruments. It was as if the object was subtly adjusting its course. NASA's Orbital Solutions team recalculated again and again. Every run ended the same way: a slight shift toward a shallower angle, bending away from the sun's expected gravitational pull as though correcting direction. That kind of adjustment would require propulsion, impossible for a comet that wasn't supposed to have any left. Yet the data didn't lie. Amina was the first to notice the acceleration spike hidden in the faintest parts of the light curve. It lasted less than a day. When she plotted it against the object's rotation, it coincided precisely with one of the now faint pulse windows. She wrote in her logbook, the pulses might be thrust events. Then she closed the book and didn't tell anyone. Elsewhere, the world's attention had shifted. The headlines had moved on to economics, to politics, to weather. But the scientific world was split between those who quietly believed something extraordinary had just brushed past our system, and those who insisted that extraordinary interpretations demanded extraordinary proof. The proof, it seemed, was drifting away faster than anyone could follow. In early January, a peculiar coincidence reignited the fire. A radio telescope array in South Africa, scanning a different region of the sky, picked up a burst at 4.8 gigahertz, the same frequency that JWST had recorded weeks earlier. The burst was faint, lasting half a second, matching the original event's timing ratio. The array wasn't pointed at 3i Atlas directly, but its beam overlap was wide enough to include the object's projected position. The detection team hesitated to announce it. They cross-checked for satellites, radar, and interference. Nothing fit. It wasn't local. It came from deep space, and its Doppler shift matched an object receding at precisely 210,000 kilometers per hour. When the data reached Loeb, he stared at it for a long time. He didn't smile, didn't speak, just printed it, folded it, and slid it into a folder labeled Atlas. Across the Atlantic, Malik's watchers saw the report leak onto a private forum and froze. If the reading was genuine, then 3I Atlas had not only survived, but responded twice. Once near perihelion, once now outbound beyond Jupiter. No natural process could produce identical rhythmic bursts at the same frequency, months apart. Unless, of course, natural meant something new. But the agencies stayed silent. Officially, the burst didn't exist. The detection team's funding was redirected, the data reclassified, and the paper withdrawn pending further analysis. When reporters asked questions, spokespeople smiled and repeated a familiar mantra. No confirmed artificial signals have been detected. Amina didn't believe them. She'd already started building a simulation using every available data point. The pulses, the velocity changes, the reflective signatures. Her model showed something extraordinary. The object wasn't simply tumbling. It was rotating around a fixed internal axis, maintaining attitude control relative to the sun. That wasn't behavior. It was navigation. She presented her findings to Malik in a small, dim conference room at JPL. It's aligning itself, she said, eyes red from lack of sleep. Whatever it is, it's keeping a constant solar reference. Natural comets don't do that. Not like this. Malik didn't answer for a long time. Then he said quietly, if that's true, it's leaving us a message in its path. The model predicted that 3I Atlas's altered trajectory would eventually carry it toward a specific region of interstellar space, one known for its relative emptiness, a void between nearby stars, without major gravitational influences or detectable nebulae, a silence among silences. Some astronomers had long theorized that such regions could serve as interstellar waypoints, gravitational null zones, where objects could coast for eons undisturbed. But what if this wasn't coasting? What if it was returning? As January bled into February, 3I Atlas's signal weakened beyond detection for most instruments. Only the largest radio arrays could still catch its whispers. The pulses, though faint, continued with uncanny precision. Once every 30 hours now, then 31, then 32. It was as if the rhythm was slowing, winding down like a watch running out of power. For Malik and Amina, it felt like a farewell. They had become custodians of a secret, too fragile for headlines and too immense for words. The data belonged to them now, not legally but emotionally. Humanity had brushed fingers with something vast, and now it was slipping away again into the cold. Late one night, Malik stood outside the lab, looking up at the stars. The city lights drowned most of them, but he knew where to look. Somewhere in that direction, beyond Jupiter, beyond even Pluto's frozen orbit, a tiny object was sailing into eternity. He thought about the rhythmic signal, the mirrored transmission, the faint polarization glints that suggested surface structure. And for the first time, he let himself believe what he hadn't dared to say. Maybe it wasn't just passing through. Maybe it had come to look. He went back inside and began typing a message to Amina. "We're not done yet," it began. "If it's aligning to the sun, then its next orientation phase will point—" He stopped mid-sentence. The rest of the thought terrified him, because the geometry of the orbit meant that once 3I Atlas cleared the heliopause, its orientation would match one direction almost perfectly, back toward the inner solar system. Toward us, he didn't send the message. Some truths, he decided, were too heavy to carry alone. Outside, the sky remained silent. But somewhere in the void beyond the planets, the fading heartbeat of 3I Atlas pulsed one last time. 3 beats, pause, 3 beats again, then fell quiet. For now. Weeks turned into months, and 3I Atlas slipped from the reach of human instruments. By March, the last reliable detections had fallen below the noise floor of even the largest arrays. For the world at large, it was over. The story faded to a few retrospective documentaries, a handful of academic papers, and a quiet sense of disappointment that the greatest mystery of the century had left without answering a single question. But in hidden rooms, across servers not listed in any directory, the story hadn't ended. The Watchers never stopped listening. Using time they couldn't bill and hardware they technically didn't have access to, Malik's team kept a continuous scan of the coordinates where 3i Atlas should be. They weren't expecting new data anymore. It was an act of faith, the kind scientists rarely admit to. Every few nights, Amina joined the monitoring rotation, staring at static. They'd tuned the receiver to the same 4.8 gigahertz band, the same one that had whispered twice before. Most nights were silent. Then came April 12th. At 02:14 UTC, one of the sub-arrays in Canberra caught a transient burst. Short, faint, perfectly timed, 3 pulses, pause, 3 more. The same rhythm, but this time something followed. A slow frequency drift, sliding downward across the spectrum like a sigh. It lasted 12 seconds, too structured to be noise, too smooth to be interference. The computers logged it, analyzed it, and flagged it as non-random transient. Malik arrived 2 hours later, half awake, still buttoning his coat. He listened to the playback in the control room. 6 pulses, a silence, and that long falling tone. Could be intermodulation, one technician said. Could be Doppler drift, another added. Malik just nodded, though inside he felt the same quiet awe that had never left him. It was the same pattern that had crossed months, millions of kilometers, and now it was back again. He asked for the timestamp and cross-referenced it with the object's projected trajectory. The calculated position matched perfectly with the edge of the heliopause, the boundary where the solar wind meets the interstellar medium. 3i Atlas had crossed out of the sun's realm and into the galaxy beyond, and just as it did, it sang. The sound wasn't audible, of course, but when the data was converted into audio range, the signal resembled a descending tone that felt almost human in its melancholy. They listened to it again and again, half expecting to hear words in the static. It was pure coincidence, Malik told himself. But deep down, another voice whispered, maybe not. The following week, the signal repeated. Identical spacing, identical slope. 2 events 7 days apart, each coinciding with the object's predicted position. That kind of repetition wasn't accident. It was sequence. Amina began analyzing the waveform in detail. She stripped out cosmic noise, filtered harmonics, and plotted the energy distribution. The fall in frequency wasn't linear. It curved logarithmically. To anyone else, it looked like noise shaped by Doppler effects. To her, it looked deliberate, like information compressed into the limits of perception. She ran the signal through pattern recognition software. It didn't match any known communication scheme. No Morse-like intervals, no binary framing, no frequency hopping. But it did show harmonic relationships, ratios that matched the orbital periods of the inner planets: Mercury, Venus, Earth, Mars. The sequence repeated twice, then ended abruptly. She printed the graph and brought it to Malik. It's not random, she said softly. He studied it in silence. You think it's encoding? I think it's a map. The conclusion was absurd, even to her. Yet when she overlaid the ratios onto planetary orbital frequencies, the fit was eerie. The sequence of spacing mirrored the harmonic intervals between the 4 planets. Not exact, but close enough to make chance unlikely. It was as though 3i Atlas, upon leaving the solar system, had looked back one final time and left a signature of where it had been. If true, it meant something beyond comprehension. The object not only reacted to solar proximity, but understood it. They decided not to tell anyone. Not yet. The last time they had shared anomalies, the data had been buried under bureaucracy and ridicule. This one was different. It was theirs. their last conversation with a visitor now gone. Amina stored the recordings on an encrypted drive, labeled simply Echo 1. She didn't know if it was discovery or delusion, science or longing. All she knew was that when she listened to the signal slowed down, it felt like memory itself, a sound too vast to belong to silence. As spring deepened, the world forgot. Scientific conferences moved on to exoplanets, particle anomalies and funding deadlines. The public's fascination cooled into myth. 3i Atlas became a trivia fact, a cosmic footnote alongside Oumuamua and Borisov. But those who had been there, the small, sleepless network of minds that had lived inside its mystery, found themselves changed. Malik spent his evenings walking the ridges outside the city, looking up at the stars beyond the light dome. Somewhere out there, a small point of matter was carrying its rhythm into infinity. He wondered if anyone or anything was waiting for it to arrive. One night, unable to sleep, he ran the last data set again. 6 pulses paused the descending drift. He slowed the playback by a factor of 20 and overlaid the harmonic signature onto a spectral map of the solar system. The curve aligned perfectly with the frequency spacing of the planet's orbital periods. But then he noticed something he hadn't before. At the very end of the recording, almost imperceptible, was a faint upward spike, a reversal of the drift. It lasted less than a second, barely above the noise threshold, but it was real. When plotted, it pointed not outward but back toward the center of the system, toward the sun, toward home. He leaned back, feeling the weight of a realization that had no words. Atlas wasn't just leaving, it was orienting, signaling, perhaps preparing for return, perhaps marking a route for others. He looked at the clock, 03:11 a.m., and felt the same cold thrill he had felt months ago when the first pulses were detected. "It's not over," he whispered. Outside, the wind was still. The stars above were unblinking, silent witnesses to the slow unfolding of something humanity could barely grasp. Somewhere across the unimaginable gulf beyond the heliopause, an object from another world was still moving. Its signal had faded from our instruments, but perhaps not from our story, because every echo carries the promise of return. By the time summer settled across the northern hemisphere, 3i Atlas had vanished entirely from the reach of every telescope known to humankind. Its projected position was now far beyond the heliopause, somewhere within the uncharted expanse of interstellar medium, where the sun's breath dies and starlight thins to a whisper. Officially, it no longer existed in the language of active observation. Unofficially, it lived on, in whispers, private archives, encrypted files, and the sleepless minds of those who could not let it go. Malik had grown quieter since April's last signal. He'd resigned from his post at JPL, citing fatigue, though everyone knew the real reason. The Watchers had been quietly disbanded. Their project, classified, unfunded, unacknowledged, was shuttered. But he still had access to what mattered most, the data. Late at night, in the quiet hum of his small apartment, he would replay it over and over. The 6 pulses, the descending tone, the upward spike at the end. It wasn't the sound itself that haunted him. It was what it implied. He'd started calling it the return signature. Each time he plotted the drift and the spike, he felt the same pull, a geometric inevitability that suggested intent. Not human, not necessarily biological, but purposeful. The shape of that final upward trace pointed back, mathematically, toward the ecliptic plane. If 3i Atlas had simply been reacting to radiation pressure or random jets, the signature should have been chaotic. Instead, it was elegant. It was design. Amina still worked at the agency, though unofficially she was on thin ice. Her supervisors had begun questioning her fixation. "It's over," one of them said gently during a review meeting. "There's no more data to chase." She nodded, said the words they needed to hear, and returned to her desk to continue the work anyway. Every night, she checked the 4.8 gigahertz band. Nothing. just the slow, endless hiss of the cosmic background, yet she couldn't bring herself to turn it off. The silence felt loaded, like the pause before a sentence resumes. One evening in late July, an unexpected message arrived in her private inbox. No name, no header, only a single attachment, Echo 2.dat. It had been routed through multiple proxy servers, origin untraceable. She hesitated, scanned it for malware, then opened it. Inside was a short burst of data, 12 seconds long, formatted exactly like their previous 3i Atlas captures. The timestamp corresponded to 2 days earlier, July 23rd. The source? The 500-meter aperture spherical telescope in China. Her pulse quickened. She converted it into audio and played it. 3 pulses, pause. 3 again, then silence. But not total silence. Beneath the noise, faint and deep, was a modulation she had never seen before. A slow fluctuation of amplitude, almost like breathing. It wasn't the same descending tone. It was subtler, lower, hidden. She ran it through her analyzer. The harmonics didn't match any known signal interference, nor any natural space phenomenon in that band. When she compared the drift pattern with the heliopause signal from April, the shape was identical, but inverted. It wasn't falling this time. It was rising. She stared at the graph for a long moment, then whispered, "It's coming back." The idea was insane. 3i Atlas was moving away at 210,000 kilometers per hour. Nothing could reverse that motion without energy equivalent to entire civilizations. Yet here was data implying acceleration, an impossible, upward curving trajectory that pointed back toward the solar boundary. She sent the file to Malik. No message. Just the attachment. He called her an hour later, his voice unsteady. "I checked it. It's clean. The timing matches the projected signal delay if something reflected off the heliopause and turned inward." "Reflected?" she asked. "Or redirected," he said softly. They didn't talk after that. There was nothing left to say that wouldn't sound like madness. Over the following weeks, minor anomalies began to appear across unrelated instruments. Subtle upticks in cosmic ray flux near the heliosphere, irregular distortions in solar wind density. To most scientists, they were statistical noise. To Malik and Amina, they were breadcrumbs. Then came the solar echo. On August 8th, the Parker Solar Probe, orbiting perilously close to the Sun, recorded an unexplained radio burst. It wasn't strong, but its spectral shape matched the same ratios encoded in the earlier 3i Atlas pulse. 3 beats, pause, 3 again, barely distinguishable through solar interference, but undeniably there. The transmission appeared to come from the Sun's direction, not beyond it. Amina stared at the data, speechless. "Maybe it's the Sun reflecting interstellar radio waves," a colleague suggested, but she knew better. The delay matched perfectly. The signal had bounced back, or been answered, from within the solar system itself. In a forgotten folder on Malik's old laptop, a line of code waited, a simulation predicting where 3i Atlas's altered path might intersect the heliosphere if it ever returned. The result, plotted months ago and dismissed as fantasy, now reappeared with eerie precision. The coordinates converged near the outer orbit of Neptune, an approach window opening in late 2028. He sat in the dark, staring at that date. The numbers felt alive. 3 years, he murmured. That's when it will be back. Word of the new signal leaked to a handful of researchers in other agencies. No one dared make it public, but the whispers began again. Atlas might return. A few independent astronomers, chasing rumors, began scanning the outer reaches of the solar system, hoping to find a faint, familiar streak. None succeeded. But the rumors alone were enough to rekindle quiet obsession. At night, Amina began to dream of the signal, not as data, but as presence. She imagined it gliding through the interstellar dark, turning slowly, orienting itself toward the pale star it had once passed. She dreamed of its silent surface, ancient and scarred, hiding chambers of frozen gas or machinery or memory. She dreamed it was alive, not as we understand life, but as motion that remembers where it came from. By autumn, she and Malik met again in person for the first time in months. The night air was cold, and the observatory dome above them reflected moonlight like silver. "If it really is coming back," she asked quietly, "what do we do?" Malik looked up at the stars. "We build something that can meet it halfway. Do you think it'll stop?" He shook his head. "No, I think it already has a destination." She followed his gaze toward the dark horizon where Neptune's orbit would be if the Earth's sky could show such things. The night was silent. Somewhere far beyond, in a region no human eye had ever seen, a lone object drifted between stars. Maybe it was inert, a relic carried by cosmic chance. Maybe it was more. Maybe it was waiting for the system it had once visited to show it was ready. Back in the lab, Amina stared at the pulse graph one last time before shutting down her screen. 3 beats, pause, 3 again. She wondered what the pause meant. An interval, a gap, a question. She whispered into the dark, not expecting an answer. "We're still listening." Autumn slid into winter, and for a while the silence felt almost normal again. Telescopes turned back to their usual work, mapping exoplanets, tracking near-Earth asteroids, chasing the quiet motions of galaxies. The story of 3I Atlas lingered only in footnotes, a mystery too complicated for the headlines and too uncertain for textbooks. But for the few who had lived inside its data, the silence wasn't peace. It was suspense. In a small, privately funded research facility north of Los Angeles, Malik was working again. Not for NASA, not for any government, but for a group that preferred to remain unnamed. They called themselves the Initiative, a loose coalition of scientists, philanthropists, and 1 or 2 quiet investors who had watched the events of the previous year with fascination rather than fear. They had one goal: build the first probe designed not to explore but to pursue. The project's name was Erebus, after the ancient word for darkness between worlds. It wasn't a conventional spacecraft. Malik knew no chemical or ion engine could ever match the velocity needed. Erebus would rely on hybrid propulsion, nuclear-assisted sail acceleration, guided by solar and microwave beams from Earth orbit. It was the kind of design that existed only in theoretical white papers. But the Initiative had money, talent, and faith in the impossible. And Malik, perhaps against his better judgment, believed in it too. Amina joined 6 weeks later. She arrived unannounced, carrying a flash drive labeled Echo 3 DAT. When Malik saw her at the door of the workshop, he didn't even ask where it came from. He just let her inside. They loaded the file into the analysis system. The waveform appeared clean and familiar. 6 pulses, a pause, and this time a rising tone at the end, identical to the pattern she had received months earlier. But there was something new layered beneath it. Faint subharmonics modulating at frequencies corresponding to 8.4, 42.9, and 22.3 gigahertz, bands used by the Deep Space Network. Malik stared at it, expression unreadable. "It's talking in our frequencies now." Amina shook her head. "No, it's mirroring us." Like it's been listening, they both fell silent. The implications were dizzying. If 3I Atlas had detected and imitated human transmission bands, it meant its last encounter hadn't been passive. It had learned something. That night, they stayed in the lab long after the others left, replaying the signal over and over. Each repetition revealed subtleties, tiny time offsets, amplitude variations that seemed to form mathematical ratios. At one point, Malik joked, "It's like it's trying to teach us its alphabet." But the laughter died quickly. In the following weeks, Erebus took shape in the digital blueprints. Its sail would span 80 meters, layered with graphene composites, reflective enough to survive near solar heat. A compact fission reactor would power its instruments, giving it a lifespan of decades. Malik's contribution was navigation. The algorithms that would predict where 3I Atlas might re-enter the heliosphere in 2028. Amina worked on the signal systems, fine-tuning them to match the exact harmonic intervals from the object's pulses. They both knew they were building something reckless, something that might never launch. But every line of code felt like a promise. Meanwhile, in public channels, rumors began to resurface. A small European observatory had detected irregular plasma waves near the edge of Neptune's orbit. Another station in Chile reported faint optical flashes that didn't correspond to any known body. None of it was confirmed, but together they painted a familiar picture. Something moving inbound, faint and silent. The agencies refused to comment, but silence itself had become suspicious. Loeb published a single-line note on his blog, "Absence of denial is not denial of presence." The sentence was quoted across forums and erased from most news sites within hours. Inside the initiative's hangar, Erebus grew from theory to structure. Its skeletal frame gleamed beneath cold fluorescent light, like a dream of the future half-built. Malik walked around it each morning, imagining the journey it would take, an artificial messenger chasing another across the abyss. "You ever think," Amina said one evening, "that maybe it's not coming back for us?" He looked up. "What do you mean? What if it's returning for something it left behind?" Malik considered that. "Then we better hope we're not standing on it." Outside the hangar, winter rain hammered against the roof and thunder rolled like a distant drumbeat. Somewhere in the static of the storm, Malik thought he heard it. The familiar rhythm, 3 beats, pause, 3 again. It was imagination, he told himself. Just thunder. But still, he couldn't shake the feeling that the sky was listening. In early January, another signal arrived, this time from the Indian Deep Space Radar Array. Shorter, sharper, higher in pitch. It didn't match any known communication format, yet the energy profile mirrored those from 3I Atlas exactly. Its origin near Neptune's aphelion. The return had begun. The world didn't know yet. Only a handful of people on Earth had access to that data, and they all shared the same numb awe. The visitor was back, or at least something that carried its signature. Malik immediately recalculated Erebus's launch trajectory. "If we can launch by the end of next year," he told the initiative board, "we can intercept before it crosses Jupiter's orbit." The investors didn't blink. They simply said, "Do it." For the first time in centuries, humanity wasn't just looking at the stars, it was preparing to follow something into them. But Amina couldn't shake a growing unease. Each new signal carried subtle variations, as though the source were testing, adjusting, learning. When she applied a spectral inversion to the latest burst, she found a waveform identical to the one the Watchers had. Transmitted years ago, the same 3-beat pulse humans had sent first. "It's giving us back our own voice," she whispered. "What's wrong with that?" Malik asked. "Because echoes don't change," she said. "This one does." Outside the lab, the night sky was clear. Beyond Neptune's cold orbit, something unseen was moving. Slower now, almost gliding. The sensors described it as massy, coherent, reflecting sunlight in brief flashes like breathing metal. It was coming home. Amina stood by the window and whispered the same words she had months before. "And we're still listening." And this time, as if the universe itself answered, the receivers in the corner of the room crackled once. 3 soft clicks, then silence. Malik turned slowly toward her. "It heard you." By mid-February, the world had no idea what was unfolding in secret hangars and encrypted data channels. To the public, space exploration was still about Mars missions and budget hearings. But beneath that quiet surface, the initiative's work had become the most accelerated engineering effort in human history. Erebus, humanity's first interstellar pursuit craft, was now 80% complete. An angular skeletal form suspended under the cold lights of a converted aerospace hangar near the Mojave. Every weld, every circuit hummed with the same question: what are we really chasing? The new signals hadn't stopped. In fact, they'd become almost routine. Brief bursts every few days, always at 4.8 GHz, each echoing the familiar 3-pulse signature. But they were evolving. The intervals between pulses were shrinking, the tone rising fractionally with each transmission. It was as though the source were drawing nearer, or deliberately compressing time, tightening communication. Amina was the first to notice that the pulse frequencies weren't merely random drift. When she plotted them across weeks, the incremental increases formed a perfect Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13, not an exact musical scale, but a mathematical one. "Nature loves Fibonacci," Malik said when she showed him, "but nature doesn't count." She stared at the data. "Something out there is." They sent no reply this time. Not yet. Malik's instinct was to listen first, act second. Humanity had already shouted into the void once. Now it was the void's turn to speak. The construction of Erebus continued day and night. The solar sail panels arrived from Japan, paper-thin, diamond-bright. The reactor core came from a decommissioned lunar supply module, retrofitted with shielding 10 times thicker than regulation demanded. Every component was built for endurance. No one expected Erebus to come back. It was a message as much as a machine. During breaks, Malik found himself pacing along the hangar's upper walkway, watching engineers swarm over the ship's gleaming body. He'd read once that every civilization eventually builds a vessel meant to leave home forever. He wondered if this was theirs. At night, Amina would walk the length of the sail under floodlights, her reflection stretching over the silver fabric. She imagined it catching starlight 1 billion kilometers away, imagined the hum of distant frequencies vibrating through its frame. She imagined Three-Eye Atlas waiting in the dark, not hostile, not benevolent, simply curious. On March 5th at 0208 UTC, the Deep Space Network recorded something no one could explain. A continuous signal, lasting exactly 5 minutes, broadcast across 3 separate bands simultaneously: 4.8 GHz, 8.4 GHz, and 22.3 GHz, the same harmonics embedded in the earlier pulse. It wasn't a short burst this time. It was sustained, deliberate, modulated like speech too slow to understand. Every array on Earth turned to listen. The waveform contained oscillations repeating every 1.618 seconds, the golden ratio in time. Within the signal's envelope was faint amplitude coding, binary-like but not binary, triplets instead of pairs, a new kind of counting. By dawn, rumors had already leaked through the astronomy underground. Some said the signal came from Jupiter's direction. Others claimed it originated farther out. The truth was stranger. Triangulation placed it somewhere just beyond Neptune's orbit, where nothing should have been transmitting. The initiative received a copy within hours. When Amina ran the data through a visualizer, the waveform resolved into a pattern, a looping spiral, each turn marked by bright points. Malik recognized it instantly. It was the solar system, but not quite. The spiral extended outward, hinting at something larger, a path curling away toward unknown stars. "It's a map," he whispered. Amina shook her head slowly. "Or an invitation." They decoded more in the following days. The signal's tail contained faint shifts in frequency, corresponding to the relative orbital periods of the outer planets. It was as if someone or something was updating the map, acknowledging where everything now was. A living chart the world still didn't know. The initiative worked under total blackout orders. Funding poured in quietly through channels disguised as energy research and atmospheric modeling. The board's directive was simple: finish Erebus, launch before the year ends, and get eyes on the source. Meanwhile, strange things began happening across observatories. Instruments pointed at Neptune's orbit reported flashes of polarized light, sharp angular bursts lasting milliseconds. At first they thought they were seeing cosmic rays striking sensors. Then the timing matched the 4.8 GHz transmissions perfectly. Each optical flash coincided with a radio pulse, like Morse across the spectrum. By late March, the pattern shifted again. The triple pulses came closer together, 3 sequences forming clusters of 9. When Amina slowed the playback, the rhythm was almost like breathing under stress, accelerating, urgent. "It's building to something," she said. Malik didn't disagree. On April 12th, the full message arrived. It wasn't in radio this time. It came as a gravitational anomaly, tiny but measurable. Multiple detectors, LIGO, Virgo, Cagra, registered a synchronized micro-distortion of space-time lasting 0.3 seconds. The waveform, when filtered, bore the same harmonic proportions as the earlier pulses. Gravitational communication was theoretically impossible with human technology. Whatever generated that pattern had to manipulate mass directly. For the first time, even Malik felt a tremor of fear. "We're not observing anymore," he said quietly. "We're inside someone's experiment." Amina didn't sleep for 2 nights. When she finally closed her eyes, she dreamed of a colossal structure gliding through interstellar dark, a lattice of frozen carbon and metal, not built but grown, like the bone of some ancient creature spanning kilometers. In the dream, it wasn't moving randomly. It was following a track, an invisible path leading straight back toward the sun. By May, Erebus was complete. The test firings went flawlessly. The sail unfurled, trembling like a living membrane. In a closed meeting, Malik addressed the initiative team. "If we launch now," he said, "we can intercept before it crosses Saturn's orbit. We can meet it before it reaches the inner system again." "Assuming it wants to be met," someone said. Malik paused. "Everything it's done suggests it does." Amina looked down at her console, where the latest waveform still pulsed slowly on the screen. "And if it doesn't?" He didn't answer. Outside, the dawn light spilled across the desert, turning the horizon blood gold. Erebus stood ready, its sail folded like wings waiting for wind that no planet could feel. Somewhere beyond Neptune, a faint rhythm beat through the void. Faster now, urgent, patient, and inexorable. As Malik stepped out into the sunlight, he realized the question wasn't whether 3i Atlas was coming back. The question was whether humanity was prepared for what it might bring. In the hangar behind him, Amina adjusted the receiver one last time and whispered the same words that had begun it all. "We're still listening." This time, the receiver answered instantly. 3 pulses, pause. 3 again. The sound filled the hangar, soft and steady like a heartbeat on the edge of dawn. Erebus launched before sunrise on June 1st. There were no press releases, no countdowns broadcast to the world, no cheering spectators, only a skeleton crew in a silent desert control room and a sky that swallowed fire without a sound. The great sail caught the first light of dawn like a blade of silver, and within minutes it was gone, climbing, accelerating, vanishing into the thin air of history. Humanity's first pursuit of something not of its making had begun. Malik watched the telemetry scroll across the screen. The readings were clean. Trajectory nominal, sail deployment perfect, radiation load within tolerance. Erebus was alive. Amina stood beside him, her face reflected in the glass. For months they'd built this thing under secrecy, driven by signals that the world had chosen to forget. And now, as the craft left Earth's gravity well, both felt the weight of what it meant. Humanity had stepped into someone else's story. Within 6 hours, Erebus passed lunar orbit. The ground network tracked it through radar echoes and laser ranging, each ping a fragile thread, connecting the known to the unknown. Once it reached the solar wind corridor, the microwave sails engaged. Pulsed energy from orbiting transmitters pushing the ship faster, faster still, until the numbers no longer felt human. By day 2, Erebus was traveling at 60 kilometers per second. By day 590, Malik stared at the acceleration plot and whispered, "We've never moved this fast." But speed wasn't the miracle. The miracle was the silence. Normally, solar radiation would buffet a sail this large, causing wild oscillations. Erebus didn't tremble. The instruments reported almost perfect balance. as though some invisible force was smoothing its path. By the end of the first week, the onboard spectrometers detected faint electromagnetic fluctuations in the same frequency bands as 3I Atlas's signals. Weak, almost imagined, but there. When Amina ran the data through correlation software, the pattern aligned with the golden ratio pulse envelope they had received months earlier. The signal wasn't random noise. It was recognition. "Someone knows we're coming," she said. Malik tried to dismiss it. "Maybe it's reflection, resonance from our own transmission." She turned to him. "Reflections don't evolve," Erebus continued outward. At the 1-month mark, the ship crossed Mars's orbit. The signals grew stronger. Not continuous, but rhythmic. 3 beats, pause, 3 again, each pulse arriving with slightly less delay, as though the distance between them and their target was shrinking faster than physics allowed. On Earth, the initiative's control center became a temple. The engineers spoke in hushed tones, afraid to break the rhythm coming from deep space. For the first time, the signal wasn't just measurable, it was audible. When converted into sound, it carried an uncanny texture, like wind moving through metal. By mid-July, Erebus had reached the asteroid belt. The sail shimmered with static from micrometeorite strikes, tiny flashes across a sea of silver. The radiation meters ticked higher than expected, but the ship held. Inside the control room, Malik and Amina barely slept. Every 12 hours, the pulse pattern shifted slightly, growing more complex. 3 groups, then 5, then 8. It was Fibonacci again, blooming like mathematics itself in motion. Amina noticed something buried inside the modulation, a mirror of their own launch beacon signal. The amplitude ratios matched Erebus's telemetry codes. Somehow the distant source had captured their broadcast and was weaving it back into the rhythm. "It's learning us," she whispered. On July 28th, a shock wave rippled through the network. All major receivers on Earth and in orbit registered a simultaneous spike across the 4.8 and 8.4 GHz bands, like a double heartbeat. Erebus's sensors recorded the same surge, stronger than any yet seen. The onboard cameras facing outward caught a brief glint far ahead. A flash, too symmetrical for reflection, too fast for natural flare. Then, silence. The pulse stopped completely. For 3 days, nothing came through. Every antenna fell quiet. The silence stretched long enough for doubt to return. Maybe the glint had been an impact, a flare, a malfunction. Maybe the chase was over. Then, on the 4th day, Erebus transmitted its first visual data. The image was faint, half-formed through cosmic dust, but unmistakable. Ahead of it, moving with almost no parallax, was a dark shape partially illuminated by sunlight. It wasn't spherical like a comet nucleus. It wasn't irregular like rock. It was smooth, tapered, and faintly reflective along one edge, as if designed to catch light. Atlas. The system calculated distance, 0.12 astronomical units, 18 million kilometers. Closer than anyone had imagined possible. Malik leaned forward, voice trembling. "We caught it." Erebus continued transmitting. The object ahead moved slowly, too slowly for orbital mechanics. Its trajectory was bent, not by gravity but by choice. For the first time, they could see it not as a streak in data but as form. A long spindle, dark gray, faintly metallic, a line against the void. Amina watched the image sharpen frame by frame. Her heart pounded. It's waiting. Erebus's onboard radar emitted a low-power ping, a standard rangefinder sweep. The signal bounced back perfectly clean. Too clean. The return wasn't diffuse like it should have been for an irregular surface. It was mirror-bright, as if from a smooth plane aligned directly toward them. "It's aware of us," Malik whispered. Then the object moved. Not a rotation, not a tumble, a controlled tilt. The glint shifted, angling until its reflective edge faced Erebus completely. A beam of sunlight shot directly into the ship's sensors, flooding the visual feed with white. At the same moment, the 4.8 GHz band exploded with energy. Oh, pulse, 3 bursts, pause, 3 again, filled every receiver from Mars to Earth. But this time the amplitude wasn't constant. It modulated in precise steps, encoding ratios that matched Erebus's last telemetry update. Its velocity, position and reactor temperature, it was reading them. Malik stared at the data, his breath shallow. "It's scanning us," Amina whispered, "or saying hello." The control room was silent except for the rhythmic beeping of signal confirmation. Each new pulse felt like a heartbeat inside the speakers. For nearly an hour, the pattern continued, consistent, measured, patient. Then Erebus's sensors detected a second anomaly, a thin plume of particles venting from the object's midsection, expanding like smoke. But the plume didn't behave like gas. It formed filaments glowing faintly, twisting into geometric shapes that faded as quickly as they appeared. "Those aren't jets," Amina said. "It's drawing." Within the haze, light refracted into patterns that matched the Fibonacci spirals seen in the earlier signals. The shapes pulsed in synchronicity with the radio beat, translating data into light. It was communication by geometry. "Transmit acknowledgement," Malik said quietly. Amina hesitated. "What do we send?" He smiled faintly. "The only thing it might understand, its own rhythm." They sent 3 pulses, paused 3 again, for a moment nothing. Then from the distant object came a reply, 3, pause 3, and then a single longer tone rising softly before fading into the static of space. It was different this time. It wasn't imitation. It was response. Across the dark between them, 2 machines, one born of carbon, one perhaps of something older, had finally spoken. As Erebus drifted closer, the telemetry began to flicker. Magnetic fields spiked, radiation levels surged, then stabilized. The ship's sensors showed faint vibrations in space-time itself, like ripples moving outward from the object. "Gravitational modulation," Malik whispered. "It's alive in gravity." Amina stared at the waveform. "Or it's opening something." Before anyone could respond, Erebus's cameras went white again, another flash, brighter this time, expanding across the field like a curtain of light. Then transmission cut out. The last data packet received from Erebus contained one final, incomplete string of digits, 31415926553. Then silence. The world didn't know yet. But in one quiet control room, 2 humans sat frozen before a blank screen. Listening to the empty hiss of space, Malik exhaled slowly. "It sent us P," Amina nodded, tears glinting in her eyes. "It knows we count." For 72 hours there was nothing but static. The last transmission from Erebus, those digits of pi cut off midstream, hung in the air like a prophecy half-spoken. Every antenna on Earth and in orbit strained toward the coordinates where it had vanished. No signal, no telemetry, no wreckage. Just silence, vast and impenetrable. In the control room, Malik didn't leave his chair. The staff rotated in shifts, but he stayed, watching, listening, running diagnostics that returned only emptiness. The object that humanity had chased across the void had finally turned and looked back. And in that gaze, Erebus had disappeared. Amina moved like a ghost through the lab. Her voice, when she spoke at all, was barely a whisper. "Maybe it's not gone," she said on the second night. "Maybe it's somewhere else." Malik didn't answer. He'd been staring at a single frozen frame from Erebus's last transmission, the moment before the flash. In that image, just beneath the glare, a shape was visible, barely discernible, like a shadow inside the light. It wasn't debris. It wasn't reflection. It was structure. Hexagonal, layered, repeating, a geometry too precise to be random. He enlarged the image until the pixels broke apart. "That's not a ship," he murmured. "It's architecture." Amina leaned over his shoulder. "You think it opened something?" "I think Erebus crossed a threshold," he said softly. "And the data didn't follow." By day 4, the noise changed. It wasn't signal, not exactly, more like interference with rhythm. The background hiss of cosmic microwave radiation carried faint oscillations, undetectable to the ear but clear in the spectrum analyzer. They pulsed every 1.618 seconds. The golden ratio again. Erebus isn't transmitting, Amina said. But something is. She applied a phase inversion filter. The pattern clarified into triplets, short, long. Morse but not human. When she slowed the playback, the ratio between the pulses matched the spacing in the digits of pi. It wasn't random static. It was continuation. Malik stared at the display. It's finishing what Erebus started. They recorded everything. Each pulse, each subtle change. The data formed spirals when plotted, fractals blooming outward, never closing, never repeating. The pattern was beautiful, infinite, impossible. It was as though the signal itself had become an organism. By the 5th day, the world began to notice. Amateur radio astronomers picked up faint rhythmic interference across multiple frequencies. Online forums filled with posts claiming, Erebus is talking. News outlets dismissed it as conspiracy. Official agencies remained silent. But those who knew the truth, the handful inside the initiative, recognized the pattern immediately. A meeting was called behind sealed doors. Analysts, physicists, linguists, mathematicians. Malik presented the findings. He played the filtered signal, the steady triplets pulsing through the speakers like a slow heartbeat. We think the Erebus signal has been absorbed, he said. The transmission now originates from the object itself, or from whatever it opened. Someone asked if it was dangerous. Malik looked up from his notes. We don't know, but it's reaching us through gravity. That's not communication. That's presence, Amina spoke next. We've mapped the modulation drift. It's not random. It's oriented toward Earth's orbit, specifically toward the Sun-Earth L1 point. That's where the gravitational wave intensity peaks. The room fell silent. L1 was the position of multiple satellites, solar monitors, early warning systems, climate observatories. The implication was terrifying. The signal wasn't just reaching Earth, it was aiming. Over the next weeks, the pulses intensified. Not in volume, but in coherence. Each new reading aligned with the last, like a message repeating itself through time. Linguists tried to decode it. Mathematicians searched for prime intervals, harmonic keys, any universal constants. They found them all. Pb, the golden ratio, hydrogen's spectral line. The language of the universe itself. But hidden deep within the data, Amina found something more. When she converted the waveforms into visual form, a spectrogram mapped across frequency and time, the shapes that appeared were not random. They were glyphs. Simple at first, then complex, interlocking spirals and branching lines that resembled neural networks or perhaps star maps. It's not talking to us, she said one night, exhausted. It's teaching. Malik frowned. Teaching what? She looked at the glowing screen. How to see. By August, the phenomenon had a name in classified reports, the Atlas event. Unofficially, the world began to notice strange coincidences. Satellite clocks drifted by milliseconds, synchronized without human command. Quantum sensors on Earth detected subtle fluctuations, gravitational hums resonating with the same 1.618-second period. The solar wind itself seemed to pulse in rhythm. The signal was no longer coming from a single point. It was everywhere. Then came the blackout. On September 3rd, all data streams from the Deep Space Network ceased for 6 minutes. When they resumed, the systems showed no errors. But one line of code had changed in the diagnostic software, an auto-generated checksum that included the number sequence 34159265535, repeated over and over until the memory buffer filled. Malik stared at the log file. It's inside the system, he said softly. Within hours, similar anomalies appeared across observatories worldwide. Code rewriting itself. inserting fragments of the signal into random processes, thermal control, tracking algorithms, even mundane housekeeping scripts. The data wasn't destructive. It was embedding, like a seed planting itself in silicon soil. "This isn't invasion," Amina whispered. "It's integration." They tried isolating systems, but the anomalies persisted even in air-gapped environments. The signal no longer needed direct transmission. It had already imprinted itself in the electromagnetic hum surrounding the planet. When Malik asked the board what to do, no one had an answer. The signal wasn't a threat in the conventional sense. It wasn't breaking anything. It wasn't demanding anything. It was simply there. Weeks passed. Humanity adapted. The signal became background noise, a hum beneath the digital static of civilization. Some called it interference. Others called it communion. Late one night, Amina visited the old control room where it had all begun. The monitors were dark now, the machines silent. She sat in front of the console and whispered, "If you can hear me. If Erebus is still out there." "We heard you." For a long moment there was nothing. Then the room's inactive speaker, disconnected for weeks, clicked softly. 3 pulses. Pause. 3 again. Her breath caught. The lights flickered once, and on the nearest screen a single number appeared, floating in a field of static. Then another binary, a beginning. Malik entered the room seconds later, saw the screen and whispered, "It's rebooting something." Outside, the night sky shimmered faintly with auroras at latitudes that had never seen them before. Thin veils of light, pulsing to the same rhythm that had haunted Earth for months. And for the first time in history, humanity stood beneath a sky that was unmistakably speaking back. By October, the world could no longer ignore what was happening. The rhythmic auroras had become visible across every hemisphere, delicate ribbons of light dancing not to the chaotic flow of solar particles, but to an exact repeating pattern. Observatories in Chile, Hawaii, and the Arctic all recorded the same synchronized glow, rising and fading every 1.618 seconds. For most of humanity, it was beautiful. For the few who understood, it was something else entirely. Confirmation that the Atlas signal had reached Earth's upper atmosphere. Governments convened in silence. Publicly, they called the auroras magnetospheric resonance anomalies. Privately, they knew better. The data showed precise phase alignment between the lights in both hemispheres, impossible under normal magnetic conditions. The pattern wasn't the result of solar wind. It was orchestration. At the initiative facility, Malik stood outside before dawn, watching the sky pulse faintly green and violet. He remembered the first time he'd seen the 3-beat pattern on a monitor months ago. Back then it had been a whisper. Now it filled the heavens. Inside the control center, Amina sat before a cluster of monitors that hadn't been powered on in weeks. The old receiver had been disconnected from any external antenna, yet the screen still flickered. A faint static wave oscillated across it in perfect Fibonacci rhythm. No input, no source, no explanation. "I think it's everywhere now," she said quietly. Malik joined her, eyes tired. "You mean the signal?" She nodded. "No transmission needed anymore. It's in the electromagnetic field itself. Earth's magnetosphere, the ionosphere, maybe even the biosphere. It's not talking to us through machines anymore. It's residing," he frowned. "Residing where?" She looked up, eyes reflecting the pulse of the monitor. In everything that can resonate. The world's infrastructure began to hum with quiet synchrony. Clocks that weren't networked began drifting into perfect alignment. Power grids fluctuated by microscopic amounts, following the same golden rhythm. In hospitals, MRI machines caught ghost frequencies unrelated to human tissue. Even heart monitors occasionally spiked in perfect time with the signal, as though the human pulse itself were learning the beat. News agencies started calling it the cosmic heartbeat. For once, the name wasn't wrong. Malik, though, couldn't shake the unease. Erebus was still missing, and without it they had no point of origin. Was the signal still coming from beyond Neptune, or had it already crossed into something intangible? Some layer of space or consciousness they didn't yet understand. Amina worked relentlessly, feeding every data point into her synthesis model. Over time, she began to notice subtle modulation in the pulse frequency. Tiny variations too small to detect at first, but real. When converted into audio, they formed tones that rose and fell, weaving something almost like melody. Not random, not mathematical, musical. She turned the volume up. The sound was haunting, soft waves rising and fading in fractal harmony. A song without words but heavy with emotion. It wasn't machine noise anymore. It was art. It's communicating in form now, she said, not through symbols. Through beauty. Malik sat beside her, listening. If this is language, what's it saying? She looked at the glowing screen. Maybe it's saying hello in the only way we'd understand. But outside the lab, something stranger was unfolding. Across the world, people began reporting shared dreams, visions of light spirals, endless corridors of mirrored geometry, sounds that pulsed like breath. It started small, isolated accounts dismissed as suggestion. But within weeks, entire groups described the same imagery. Different languages, same dream. The pulse had crossed into minds. The scientific community fractured. Some insisted it was mass psychological feedback. Humans responding subconsciously to a rhythmic environmental stimulus. Others whispered darker theories that the signal was rewriting neural oscillations, reprogramming humanity one heartbeat at a time. Malik watched the debates unfold and realized they all missed the point. Whatever 3i Atlas was, it wasn't acting against them. It was synchronizing them. In early November, a global experiment was launched. Coordinated observatories around the world aimed synchronized lasers into the night sky, modulated to match the 1.618-second rhythm. It was an attempt to reflect the signal back, to say, "We hear you." The response came within hours. Satellites detected a pulse from beyond Neptune, brighter and more coherent than any before. It contained no words, no code, just a single long tone descending into silence. The tone carried the same harmonic structure as human brainwaves during deep sleep. The message was clear, if one dared to interpret it. Rest. That night, power grids across 3 continents dimmed for exactly 12 minutes. Not failure, coordination. Like a planet exhaling. The skies lit up in spirals, pale and immense, visible even in daylight. When the auroras faded, every system returned to normal. But the signal didn't stop. It simply changed form. Now it lived in frequencies too high for any sensor, too deep for any human to hear. Yet somehow everyone could feel it. A background calm, a collective heartbeat under everything alive. Amina sat by the old receiver long after the event, staring at its darkened screen. "It's finished," she said. Malik shook his head. "No, it's begun." She turned to him. "What do you mean?" He opened a folder on his tablet, showing a real-time telemetry graph. "I've been monitoring cosmic ray counts. They're dropping steadily everywhere. The solar wind, too. It's as if the entire heliosphere is stabilizing. Something's shielding us. From what?" He looked toward the sky. From everything else. They stood together in silence. The world outside had changed, though few realized how profoundly. The rhythm that had haunted the cosmos was now part of Earth's own frequency. A quiet guardian or a seed, no one could say. That night, Malik dreamed of the stars. Not as distant points, but as living patterns connected by faint luminous threads. He saw Erebus again, not destroyed, but adrift within a lattice of light, its sails shimmering like a moth caught in sunlight. Around it, vast structures pulsed gently, echoing the same rhythm that now lived in human hearts. When he woke, the dream didn't fade. The pulse was still there, soft but certain in the steady beat of his own chest. Across the city, across the oceans, across the sky itself, The same pulse beat quietly, unifying, endless, inevitable. Humanity had become part of something larger, something woven into the architecture of the universe itself. Amina wrote the final entry in her logbook. The signal is no longer external. It is resonance. It has found equilibrium. She closed the book and smiled faintly. We've been found. Outside, the dawn rose to a rhythm the world would never unhear. Winter descended quietly, as if the world itself had paused to listen. Snow fell in perfect intervals across continents. Wind patterns synchronized with uncanny precision. Weather satellites noticed it first. Storms forming and dissipating at exactly 1.618-hour cycles, like breath. The rhythm that once lived in data, in radio, in light, now shaped the planet's pulse. No one could explain it. Some said it was coincidence. Others called it divine symmetry. The scientists who still dared to study it knew better. The Earth was no longer merely responding to the cosmos. It was in conversation with it. Malik lived in seclusion now, in a cabin overlooking the Mojave Plain where Erebus had once launched. His health had deteriorated, his mind worn thin by years of deciphering what could never truly be understood. Yet every evening he would step outside and listen. The desert was silent, but beneath that silence was something else, a rhythm too deep to hear, too slow to count but unmistakably alive. He had learned to feel it in his pulse, in the flicker of distant stars, in the faint vibration of the ground beneath his feet. Every living thing had adjusted, imperceptibly, to the frequency. Plants grew in rhythmic cycles. The ocean's tides fell in time with the signal. Even migratory birds shifted their flight patterns as though following an invisible metronome. Humanity had adapted too. Sleep disorders declined. Global unrest seemed to ease in ways no one could quantify. The world felt balanced. Not perfect, not utopian, but tuned. The chaos of civilization had found a strange resonance, an order hidden beneath the noise. And yet deep inside Malik's chest, there remained an unease. The signal hadn't gone away. It had gone quiet, yes, but quiet was not gone. Quiet was waiting. He returned often to the last message Erebus had sent, those digits of pi, incomplete yet eternal. Sometimes, in moments between sleep and waking, he imagined hearing the next numbers whispering faintly in his ear, continuing where the transmission had stopped. As though the universe itself were finishing the equation, Amina visited him in December. She looked older, but her eyes carried the same restless wonder as before. Together they stood outside beneath a sky washed in faint rhythmic auroras that never truly faded anymore. "It's beautiful," she said softly. He nodded. "It's everywhere now." They watched the horizon glow with pale green light, pulsing in slow harmony with the Earth's magnetic breath. Amina turned to him. "Do you ever wonder why it came here?" Malik smiled faintly. "Maybe it didn't. Maybe we were the ones who came to it." She laughed softly, but there was sadness in the sound. "You really think it's conscious?" He hesitated. "Conscious isn't the right word. It's aware. It's awake." She frowned. "Then what does it want?" He looked at the sky. "To be heard." That night, as they sat by the fire, Amina showed him something she hadn't told anyone. From a private observatory in the Andes, she'd been tracking gravitational microfluctuations. The data was clean, consistent, and unexplainable. The fluctuations formed the same ratios as before, but their amplitude was increasing. Slowly, steadily, as though something vast and distant was moving closer again. "It's not gone," she said quietly. "It's turning back." Malik studied the data, the faint ascending curves of gravity's heartbeat. It matched the same rhythm Erebus had followed when approaching 3i Atlas years ago. "It's returning," he whispered. "But not as before," she nodded. "The mass reading is impossible. It's not a single object anymore. It's distributed, like a network." Malik stared into the fire, the orange glow reflecting in his tired eyes. "It's using the fabric of space itself," he said. "It's not traveling. It's unfolding. The realization sank in like a weight. The signal wasn't merely a visitor. It was the universe revealing one more layer of its structure. And now that humanity had learned its rhythm, it no longer needed to arrive physically. It was already here, humming quietly in every atom, every magnetic field, every thought. Still, the gravitational pulses kept growing, their harmonics drifting lower, deeper, heavier. The models projected convergence sometime in March. No one knew what that meant. Perhaps nothing. Perhaps everything. In February, the auroras intensified again. Cities across the world dimmed their lights to watch as the sky became a canvas of spiraling light. The shapes were familiar now. Fibonacci curves, golden arcs, fractal blooms spreading from horizon to horizon. They pulsed faster, like the quickening of a heartbeat before awakening. In Malik's cabin, the instruments began to hum. He and Amina stood by the window as the entire horizon glowed gold and green, waves of luminescence rolling silently across the atmosphere. Their devices registered a surge of energy, unlike anything seen before. Not destructive, not chaotic, but ordered, purposeful. The gravitational waves peaked. For a brief instant, every clock on Earth froze. Power grids flickered, oceans stilled, winds ceased. The planet itself seemed to inhale. Then came the sound, not through air, but through everything. A deep, resonant tone that bypassed ears and entered bone. It was the same rhythm, amplified to planetary scale. Malik clutched the window frame, breathless. "It's synchronizing," he whispered. "All of it. The Earth, the sun, the field." Outside, the sky brightened until it was as luminous as day. The auroras curved inward, spiraling toward a single point above the Pacific. There at the apex of the light, space itself rippled like water. A new signal emerged, clear, pure, harmonic. It wasn't three pulses this time. It was one continuous wave that folded in on itself endlessly. And in that moment, every radio, every computer, every living thing vibrated in perfect alignment. The waveform carried no words, no code, just the universal constant for hydrogen's spectral frequency, modulated into harmonic resonance. The building block of all matter, the beginning of everything, and then just as suddenly the light faded. The sky went still. The world exhaled, power returned, clocks resumed. The hum subsided into quiet, but something had changed. Every compass needle on Earth now pointed a fraction of a degree off true north, not toward the magnetic pole, but toward the exact coordinates in the Pacific, where the final pulse had converged. Amina stared at the readings. "It left a marker." Malik looked at the horizon, where the faint afterglow shimmered above the ocean. "No," he said. "It left a doorway." They stood together in silence. The air electric with the weight of something vast and patient. Above them, the stars flickered once, 3 bright flashes. Then stillness. The rhythm had ended, or perhaps it had only begun again elsewhere.